models predicted it at 90%, some at 89%. They're logically right in two significant figures. So, azeotrope. So, at 1 atmosphere, which if we use torr, 760 torr, it is 0.8943 mole fraction ethanol. And as you move towards vacuum, it moves to the right. So if we were to get significant vacuum, to reduce it to 90 torr, the azeotrope moves to 0.9843, 35. And if you go below 70 torr, guess what happens to the azeotrope?
It's gone.
It's gone. Exactly. No azeotrope. Now, of course, operating at such high vacuum is not going to be cheap. And also, you have to worry about flammability, etc. But you can certainly move the boundary by changing the pressure. And the pressure swing, what you do is, we can have two columns. So in both cases, we have two columns. And let's say this is my original feed, and let's say here is the azeotrope at, let's say, pressure 1. We're going to take the original feed and mix it with the distillate of the pressure in the second feed. And let me shrink it a bit so that you can see both together. Here we go. We're going to be distilling in the second pressure in this region, so the distillate is going to be this composition. So what we're feeding the first column is my fresh feed and the distillate from the second column. And so here is, this is from the second column. Here is my fresh feed. Sorry, this is here. Sorry, here this is from the second column. Here is my fresh feed. So this fresh feed here, distillate from the second column here. What tells me where F1 is going to be? So here is fresh. Here is D2. What tells me where the feed is going to be located?
Composition?
Liver rule again, guys. Okay? Liver rule works everywhere. So that gives the F1 that comes in here, and this one is to the right side of the azeotrope, so you can get pretty close to pure A. So your bottom can be pretty close to pure A. And your distillate is going to be D1, which is on the other side of column 2. And in column 2, we can get pure B. And because it is a minimum boiling azeotrope, what do you see the two pures coming up? Both as bottoms. Okay, so I hope you clearly understand why separation factors are meaningless when you have azeotrope. And why you should never use a shortcut distillation column if you have azeotrope compositions on both sides. Oh, that doesn't mean you did it. Okay. Good. All right. And I will mention that, of course, other means are membrane separations that we can't use. Okay, so you all have had an excellent safety course, and so perhaps what I'm going to do now is going to be just for a reminder, but safety is so important that we definitely need to be addressing it in the reports, in the design reports. So I will do a brief overview of the safety class. Maybe there are a couple of things that I will do that you haven't covered, but new topic, safety, and I have posted deliverables 7, 8, I think, until 9. One of them has some instructions on safety. I will expand it somewhere. I just posted it. That will be preliminary so that you know. But basically, when you have put your design, you need to also consider detailed safety considerations once you have the full design, and you know what compositions are where, etc. Let me ask you something. If you have a composition that is within the flammability limits, and you need to operate it near atmospheric pressure, what pressure should you choose?
Slight vacuum. What do you mean?
What happens if you put slide right?
You might get oxygen in there.
You might get oxygen in there. Is that a good idea? You have something that potentially could be flammable, and you can allow some air to leak in. That can, is oxygen going to be removed, or is it going to be building up in your process? Okay, you need to make sure that you don't have any oxygen build up. Okay, so maybe that's a case where you have a high, slightly excess pressure. What is a case where you wouldn't have, where you definitely would not want to have any excess pressure? Let's say you deal with something extremely dangerous, and I'm happy to say this no longer exists in the chemical engineering building, but for many years, the ground floor of the main chemical building had phosphine and arsine lines. Phosphine is odorless, parts per billion killed basically instantly. Of course, there were high alarms, etc. What was a big safety feature there? In addition to, of course, having the lines and sensors all over the place, what was the other thing that was making it safe?
Did you guys have little birds?
In terms of pressure. The whole, Rolando. Hmm? Louder. No, rupture disk is for high pressure. How do you want to make sure that the leak would not leak elsewhere in the building? Say it. Yes, the room was under vacuum. Okay, the room was under vacuum. I was always worried because our department, as you know, is neighboring a sinkhole. The walls had been moving, so I was very late when finally they decided it's not safe to have it here. Yeah. And it was forced to close down. So this has stopped existing for over a decade.
That's really not long.
I mean, they had done everything that possibly could be done to make it as safe as possible. But still, huh? Because research has been done on this. Very major research. Okay. So always think about what is safe. All right? Often if you don't want oxygen to get in, you have to operate at slightly higher pressure. But that could mean that the leak releases small amounts of what you have in the atmosphere. If it's something that at very low concentrations poses no problem, then probably you want to have positive pressure in that plant. But if it's something that is extremely toxic for shrimp, for example, absolutely not. So one of the things I want you to go through your design is list any possibilities. So let me do a review of some of the things that I would like you to look at. So you all know that common plant accidents, which are the most common plant accidents? Fires, explosions, and toxic release. These are the three most common. And the most common source is organic solvents for chemical industry. You all know the fire triangle. And is it always a fire triangle? When is it not a triangle? Say it, it's a dust, right? What do we have instead of a triangle instead of dust? Pentagon, very good. All right. So, you all know the fire triangle, right? How am I doing on time? Oh, you're great. Yeah, great.